You ever just stop and think about what's actually happening when you click a link? I mean, you tap your screen and boom, less than a second later, a whole website from a server maybe halfway across the planet just appears. It really does feel like magic, right? But it's not. It's actually one of the most brilliantly organized systems ever created.
So really, how does that little click travel through this crazy maze of cables and routers and satellites to get you exactly what you wanted? Pretty much instantly. It's a great question, and it gets right to the heart of, well, how our entire modern world is connected. Well, the answer, as you probably guessed, isn't magic. It's actually this incredibly clever 7-layer plan. Think of it like a universal rulebook that every single connected device on the planet has to follow. It's what brings order to what would otherwise be just total chaos.
So let's talk about this universal rulebook. Before we dive into the layers themselves, we've got to understand the massive problem this whole thing was designed to solve in the first place.
Just think about it for a second. You've got iPhones trying to talk to Androids, Windows PCs talking to servers running Linux. You have devices from literally hundreds of different companies. How in the world do you get them all to speak the same language and communicate flawlessly? You need a standard, a universal translator, basically. And that standard is called the OSI model. Now, it was developed way back in 1984, but stick with me. The Open Systems Interconnection Model is basically a universal blueprint. Its whole job is to take the gigantic, messy task of network communication and break it down into smaller, much more manageable pieces. And here it is, the famous 7-layer stack, from the actual physical cables at the very bottom all the way up to the apps you're using on your screen at the top. Every single piece of data has to travel up or down this stack. We are absolutely going to break this down, but first, why? Why even bother with layers at all? Okay, so this whole layered approach is kind of genius, and for a few really good reasons. First, it makes troubleshooting so much easier, right? If a web page is loading slow, you can actually isolate the problem to a specific layer. Is it a bad cable down at the bottom? Or maybe a software bug way up at the top? Second, it allows for innovation. A company can invent some brand new, super fast Wi-Fi tech at the physical layer, and the folks making web browsers don't have to rewrite a single line of code. See, each layer can evolve on its own. All right, to really get a handle on how this all works, let's use an analogy. It's actually a pretty simple one. I want you to stop thinking about digital signals for a minute, and instead think about sending a physical package, like a real box you're mailing across the world. So this whole journey your data takes, it really just breaks down into two main parts. First, you've got what we'll call the packaging department. This is where your data gets all prepped and ready to go. And then you have the Global Postal Service, the part that handles the actual, shipping and logistics of getting it where it needs to be. Okay, let's start at the top of the stack, in the packaging department. These are the upper layers, and this is where your data gets ready for its big trip. So at layer 7, the application layer, that's you. You're in your web browser, you're writing your letter, you're making your request. Then your data moves down to layer 6, the presentation layer. This thing is basically a universal translator. It encrypts your data, it formats it, so the computer on the other end can actually read it. And finally, before it leaves the packaging department, it hits layer 5, the session layer. Think of this as the manager who picks up the phone, establishes a direct line, and just makes sure the conversation between the two computers stays open and organized until you're done. All right, your package is all prepped and ready. Now it's time to actually ship the thing. This is where the lower layers come in, and trust me, these are the real workhorses of the internet. So now we're in the shipping department. First stop, layer 4, the transport layer. Here, your big letter gets chopped up into smaller, numbered packets. It's kind of like taking a huge book and mailing it one page at a time. That way it's easier to ship and you can reassemble it in the right order on the other end. Okay, next up, layer 3, the network layer. This is where the final destination IP address gets stamped on every single one of those little packets. This is like the full global address of the house on the other side of the world. Then it goes to layer 2, the data link layer. This one's a bit different. It adds the address for just the very next stop on the journey, like the address of the local post office your delivery truck is heading to first. And finally, we hit rock bottom at layer 1, the physical layer. This is the actual delivery truck itself. We're talking physical cables, fiber optics, Wi-Fi signals, the stuff that actually carries the data as raw ones and zeros.
Okay, so that's the theory, right? The whole 7-layer cake. But let's make this real. Let's connect this abstract model to the actual technology you and I use every single day.
And this is where it should all click into place. We're focusing on these particular layers because they have real-world parts you can practically touch. So, layer 7, the application layer, that's your web browser. Chrome, Safari, whatever you're using. Easy. Layer 3, the network layer, that's what handles your device's IP address, its unique address on the internet. Then you have layer 2, the data link layer, which is your computer's physical network card, the thing the Ethernet cable plugs into. And layer 1, well, that's the literal Ethernet cable itself, or the Wi-Fi signal floating through the air. And this image just nails that connection perfectly. On the left, you've got the abstract blueprint, the whole grand plan for the system. And on the right, that's the real deal. A humble copper cable that's doing all the heavy lifting for layer 1, turning our data into actual physical signals. This is literally how the blueprint becomes reality.
So, I know what you might be thinking. This model is from 1984. That's ancient. Is it even still relevant? And the answer is a huge, resounding yes. In fact, you could argue it's more important now than ever, because this old model is the quiet foundation for pretty much everything coming next.
Seriously, all of the most exciting tech innovations happening today, they're being built directly on top of this 40-year-old framework. Just take 5G, for example. It's a total revolution in wireless speed, right? But what is it really? It's an innovation happening at the lower layers of the OSI model, the physical and data link layers. And its projected growth is just staggering, nearly 60% per year. That shows you how critical this foundational model is for building the future.
Or how about a newer concept called SASE? That stands for Secure Access Service Edge. It's a whole new architecture that merges networking and security into one cloud service. We're talking about a market that's projected to be worth almost $6 billion, and it only works because the OSI model separates these different functions into layers.
So yeah, all those buzzwords you're hearing about constantly, Wi-Fi 6, 5G, multi-cloud networking, digital twins, even the very foundations of the metaverse, they all depend on this structured, layered approach to communication. They're just new, fancy technologies being slotted into the different layers of this classic blueprint.
So, after all that, what's the big takeaway? What should you remember? It's this. Behind every single click, every movie you stream, every video call you make, there is this silent, brilliant, unseen architecture that's keeping it all running like clockwork.
And this quote just sums it up perfectly. The OSI model organizes thinking about networks and gives novices, journeymen, and masters a common computer networking language. It's that common language that's key. Whether you're a top-tier network engineer or just someone who's curious about how the internet works, this model gives everyone a map to understand this incredibly complex world.
And that brings me to one last thought to leave you with. You know, in the tech world, people sometimes joke about a layer 8. That's the human layer, where user errors happen. But as our world gets more and more virtual, with things like the metaverse on the horizon, what will our layer 8 really be? What's the next layer that governs not just how our machines talk to each other, but how we live and interact inside of them? It's a big question and definitely something to think about.